Hello and welcome to your geometry recording of the week. It is the week of January 31st. We are about to jump right into February. And also we are in week 4 when you go to look for your assignments in the weekly folder. We're in week 4. So as always, I like to start with a warm-up question. And just a reminder to make sure you've got your math notebook out right now and you're ready to take good notes, that if I asked you to send me a picture of your notes, you could do so. So the warm-up question is sine of what degree measurement, because remember after sine or cosine or tangent, we always put the degree measurement. So sine times what degree measurement is going to equal 0.5. So I do want you to take a quick moment to pause this recording and try this question in your math notebook, and when you're ready to check your work with mine, go ahead and click play. All right, so remember we are looking for a degree measurement. We're looking for a degree measurement. And a trick that will help you, or just something to remember, is whenever you're trying to find an angle measurement, or degrees, angle measurement, you always want to use the inverse of the sine, cosine, or tangent. So anytime we're trying to find an angle measurement, we do want to use the inverse. So with that said, make sure you've got your calculator out right now and it is in degree mode. And I want you to click the inverse sign, which is that sign with a -1 right next to it, and then 0.5. And what do we get? So the inverse of sine, 0.5, is 30 degrees. So the reason we always take the inverse is, if you think about it, to solve for x, to get x all alone, we would have to divide it by sine, because sine is being multiplied by x. So the opposite of multiplying is dividing. So then we'd have to come over here and divide this side by sine as well. And remember, we can always rewrite when we've got something in the denominator, like if we've got 1 over x, that's the same thing as saying x to the negative first power. Remember, our exponent rules. So that is how we can actually rewrite our sine to the -1 power times 0.5. That's how we got that inverse. And it equals 30 degrees. So I'm going to go on to the next slide. So if you need more time here, go ahead and click pause. So this week, we're going to do a grade check assignment just so that you guys are aware of how you're doing in the class and answer some questions about how you're doing in the class. We're going to do a review of Unit 5, where you guys are going to take a step back and look at all the big ideas from Unit 5, and then you're going to work on a Unit 5 project that's really going to help prepare you for the Unit 5 test that is coming your way next week. So this week will be a great time to review and get you ready for that Unit 5 test that's coming next week. So some quick reminders: make sure you're checking your grades often and that you're actually clicking on the assignment that's graded to open it up and see what you actually missed and read my feedback. And if you choose to redo assignment, or if you're turning in late work, remember you do have to email me or message me so that I know to regrade your work or grade it if it's late. And then please do be patient when you submit late work or redos for grading. My priority is to grade the current assignments first. So I'm honoring the time of those students who are submitting their work on time, and I'm going to grade that work first, and then I go back and grade redos or late work. I will get to it. I will grade everything. I just ask that you be patient if you submit late work or redos. Things to remember for Unit 5. Calculators. If you're using a TI-83 or 84 or 82, make sure you're in the degrees mode. And to get there's a radian mode and a degrees mode. We want to be in the degrees mode. So to get to the degrees mode, there is on your calculator near like the right side of all the buttons, there's a button that says mode. It says mode. Click on the mode, and then if you scroll down to it should be like the third column down, you're going to see radians and then degrees. and then make sure that the degrees is highlighted. That's the mode we want to be in. And then SOHCAHTOA. Remember, these are our trig ratios that are going to help us find the missing sides or missing angles of right triangles. So just a reminder that we can only use the sine, cosine, and tangent trig ratios with right triangles. So you can only use SOHCAHTOA when you're looking to solve for missing angles or missing sides of right triangles. And then another reminder from Unit 5 is when you are trying to find an angle measurement, and this is what we did in the warm-up of a right triangle, we want to use the inverse of either sine, cosine, or tangent. So those are just some little reminders as we start to review the Unit 5 content. So keep that stuff in mind. All right, so let's hop right in and start reviewing the trig ratios we learned that will help us solve for missing side lengths or angle measurements of right triangles. So again, remember, we can only use trig ratios with right triangles. They have to have a right angle in them. And if you look down at these two that we're going to solve, they both have a right angle in them. So the first one, we see our unknown is right here, x, and we're trying to find this side length that's labeled x. So let's figure out which trig ratio is going to help us find that. So if you want, this is a great time to review on your own. If you feel like you've got this already and you want to try this problem on your own, go ahead and click pause and work through both 1 and 2. And then you can check your work with mine. Otherwise, if you need some reminders, follow along now. So we've got this angle measurement right here that's given to us. And we always want to start with a reference angle measurement to help us figure out which trig ratio we're going to do. So what we do is we kind of place ourselves at this angle measurement and look at the sides given in relation to this angle measurement right here. So what two sides are we given in relation to this angle measurement? Are we given the opposite, the adjacent, the hypotenuse? Which two sides are we given? So this side over here that's labeled 46, that's the opposite side of that angle. So we're given the opposite, and then this angle here, or I'm sorry, the side measurement here that's labeled x is the adjacent side. So we're given the opposite and the adjacent. So we've got SOHCAH or TOA that's going to help us figure out which trig ratio. We are given the opposite and the adjacent, so that means we're going to use TOA, which is tangent. So we're going to say the tangent, and then we always multiply the tangent times the angle measurement, equals the opposite, which is 46, over the adjacent, which is x. So how do I solve that? Well, first I'm going to, I want to get x into my numerator because right now it's in my denominator. So what I'm going to do is I'm going to multiply both sides times x. So I'm going to have x times tangent 51 and multiply by x over here, and that cancels those out. So now I've just got x times the tangent of 51 equals 46. To solve for x, x is being multiplied by tangent 51, so I'm going to divide each side by tangent 51. And now I'm going to let my calculator do the work. So I'm going to type into my calculator 46 divided by tangent 51. And I'm going to round to 2 decimal places, and I get 37.25. That is the length of side x by using the tangent ratio. All right, so looking at our next problem, we're trying to find the degrees, the angle measurement right here. We're trying to find an angle measurement. It's still going to be our reference point to setting up our trig ratio. So what two sides are we given in relation to that missing side length that we're trying to solve for? We're given the opposite side over here, side 8, and then we're given the hypotenuse. So opposite and hypotenuse, we're going to use the sine function. So we're going to say sine of x, because we always know that's where we put our angle measurement. We don't know that. Over the opposite over the hypotenuse. And now, if we think back to how we did our warm-up problem, anytime we're trying to find an angle measurement, we always use the inverse. So we're going to take the inverse of sine times 8/13. So grab your calculator and take the inverse of sine, and 8 divided by 13, opposite over hypotenuse. I'm going to round to 2 decimal places, and I get 37.98 degrees, because we found an angle measurement. So this is our value of x. I'm going to go on to the next slide, so if you need more time, go ahead and click pause now. Make sure you take down good notes that will help you as you do this week's assignments, and let's go on to special right triangles, so 30, 60, 90 degree triangles. Again, we use this method for right triangles as we have that 90 degree angle right there. So we use the patterns of special right triangles to solve for right triangles. So I put over here the patterns that occur. So remember, between 60 and 90 degrees, it's just going to be x. Between 60 and 30, if we know x, we're going to multiply it by 2 to get the length of the hypotenuse. And then between the 30 and the 90, we would take x and multiply by radical 3. So we've got a 30, 60, 90 triangle right here, and we've got some missing sides. So I'm going to go ahead and put this 30 degrees in there as a place marker. We know the hypotenuse, and we want to find the other 2 sides. So how do we do that? So again, if you want to go ahead and click pause and try this problem on your own, if you think you're good at this and you want to get some practice before the test next week and then check your work with mine, go ahead and click pause now, and then play to check your work with mine. Otherwise, I know that we are given the hypotenuse. It's 40 degrees. Over here, I see that the hypotenuse is represented by 2x. So what I always like to do is find what x equals, because once I know what x equals, it's really easy to go around and plug it in to find the other lengths of the other sides. So I know that 2x represents the hypotenuse, and in this case, the hypotenuse is given as 40 feet. So solve for x, divide each side by 2, and I get x equals 20. So now that I know x equals 20, it's really easy for me to find the length between the 60 and 90 degree angle, because it's represented by the value of just x. So between 60 and 90 degrees, that's this leg right here. So they're in a little different orientation, but that's what we want to make sure that we know. Between the 60 and 90 degree angle, it's going to be b equals 20 feet. And then to find the length of angle, or of side A, side A is this one between the 30 and the 90 degree angle, which is here on this triangle. And A would have to equal x times radical 3. Well, we know x is 20, so we're just going to take 20 and multiply it by radical 3. And that's our value for A. Here's our value for B. So again, my method, I always like to solve for x. So whatever side I'm given, I always say that given value equals 2x or equals x radical 3, and then I'll solve for x and plug in the values. I'm going to go on to the next slide now, so if you need more time, go ahead and click pause. Law of cosines and sines. We haven't really talked about this yet, so I thought we should before we take the Unit 5 test. So we were introduced in the last session in Unit 5, the law of cosines and sines. So why do we use the law of cosines and sines? We use the law of cosines and sines to solve triangles that are not right angles. So far, everything we've learned so far, we can use to solve for right triangles. So we need something that will help us solve for missing side lengths and angles of non-right triangles, and that is going to be the law of cosines and sines. So when do we use the law of sines? So let's focus on the law of sines first. The law of sines first. So we use the law of sines when we're given 2 side lengths and an angle. So that would be like case 1. We're given 2 side lengths and an angle. Or when we know two angles and one side, and we want to get the opposite, we want to get the side opposite of a known angle. So these are two cases. So either you're going to use the law of sines when you know two sides and an angle, and we want to find the measure of an angle opposite the known side. Opposite the known side. Or when we have two angles and we want to know a side and a side length, and we want to know the side length opposite one of our angles. So in both cases, you must already, let me highlight this, in both cases you must already know a side and an angle that are opposite of each other. So notice we have to have an angle and a side that are known that are opposite of each other to use either one of these. In each of those cases there's an angle and a side opposite one another that are both given values. So how do we use the law of sines? We take a side length A and we put it over the sine of that opposite angle A, so the angle that is opposite that given side length. Same with, we can set it equal to, I'm going to try to change my highlighter color here, side B, and opposite side B is the angle that goes with that. So these are opposite, the angle and the side. Notice that. And then the same with the C. So you only need to use two of these. You only need to set up a proportion. So you can use any of these two. So we're just setting up a proportion, so we can use the side A and B, or B and C, or C and A. We only need to use two of these ratios to set up a proportion. So let's see an example. Let's see an example. We're going to set up a proportion using the law of sines to solve for the triangle below. First, note that this triangle is not a right triangle. There are no angles in it, or no right angles, so we know we can use the law of sines. We're trying to find this angle measurement right here. Well, we're given this angle here and the side directly opposite to it. So that's what I'm going to start with setting up, is the ratio with our given information. So I'm going to say 49 over the sine of 115. Remember, the angle always goes with the sine. We're going to set it equal to, we're given side length 16, and we want to find that value of x that represents the angle measurement. So how do we solve for proportions? We cross multiply. So I'm going to cross multiply, and I'm going to have 49 times sine x equals 16 times sine 115. So we want to solve for x. So I'm going to go ahead and divide each side by 49. Divide each side by 49. And now I've got, the 49s are going to go away here. Cancel out, right? And I'm left with just the sine of x equals 16 sine 115 divided by 49. So how do I, if I'm trying to solve for x, and x represents an angle measurement, what do I have to do here? Think back to our warm-up problem. So anytime we're trying to find an angle measurement, we have to take the inverse of the trig function. So we're going to take the inverse of sine, and I'm going to plug into my calculator, really just sine to the -1 equals all of that. I'm going to plug that all in. So I'm going to take the inverse of sine, and I'm going to put 16 times sine 115, all divided by 49. And if you want, you can do this in steps. Like you can take 16 sine 115. So if I did that, if I took 16 times sine 115, if I just do my numerator, I would get 14.5. And then I would divide it by 49. So what I would be entering in my calculator, sine -1, all that. Or you can do it all in one keystroke. And whichever you do, you should get, let me type this in my calculator. And you should be checking your calculator too, making sure that you can get the same answer as me. I got that x equals 17.6 21 degrees. And that would be our answer. That would be our final answer. So we use the law of sines to help us find that missing angle measurement. So sometimes you might be finding angle measurement, sometimes you might be finding a side length, but either way you're still going to set up a proportion and cross multiply to solve. I'm going to go on to the next slide, so if you need more time, go ahead and click pause. I do want to get the law of cosine, so we're going to switch that one. Skip it. Law of cosines. So specifically, when we know two sides of a triangle, when we're given the two side lengths of a triangle, and their included angle, so remember included means sandwich, the angle sandwiched between. So if we're given side A and side B and angle that angle C is sandwiched between sides A and B. So that's angle C is the included angle. If we're given two sides of a triangle and the included angle, then the law of cosines orders us to find that third side. So if we're trying to find this third side. So the law of cosines, we always take so let's say we're trying to find angle C here. Let's say that's the angle that we're trying to find, or I'm sorry, not the angle, the side. Let's say we're given side B and A and angle C, we're given those, that's why they're all blue. Let's say we're given all three of those measurements and we're trying to find side C. So what we would say is we would say side C squared, because we always start with the side we're trying to find. That side squared equals, we're going to square the other two given sides, subtract 2 times those given side lengths times the cosine of the angle given. So let's see an example. It's always easier when we see an actual example. All right, so here we're given this side, and the included angle measurement. And we're trying to find the length of C. Trying to find the length of side C. So using the law of cosines, we know that we're going to take C squared. We don't know what that is. Set it equal to, actually I'm just going to go underneath here, equals A squared. This side is going to be our A because it's opposite angle A. This side over here would be our B because it's opposite angle B. So A squared plus B squared minus 2 times A times B, which is 11, times the cosine of angle C, which is 37. So now all I need to do is the math and make sure I'm doing it in the correct order of operations. So what I'm going to do is I'm going to simplify all this stuff right here. I'm going to do this right here. I'm going to do 2 times 8 times 11 times the cosine of 37. And when I do all that, I get minus 140.56. I like to go to 2 decimal places. And we've still got 8 squared, which is, I know is 64. So I'm just simplifying everything in here. Plus 121, because I know 11 squared is 121. So order of operations, now I can start doing addition and subtraction as I go from left to right. So, but order of operation always tells us that we are going to do our multiplication first. And our powers. I should have done the powers first, and then the multiplication. But we're good to go. So 64 plus 121 minus 140.56, just entering it in the calculator. I get C squared equals 44.44. Am I done? No, I've got C squared and I want to just solve for plain old C, get C alone. So how do I undo a square? I take the square root. Whatever I do to one side, I do to the other. So the square root of 44.44 is 6.67. So C, this side length of this triangle, the non-right triangle, is C equals 6.67. So I'm going to go on to the next slide, so if you need more time, go ahead and click pause now. Make sure you take this down in your notes. And that's all. So what can you use? This is a key phrase assignment, so this is the week of January 31st. And the key phrase question you need to answer is, what do you use? There's actually two things you can use when you're trying to find the angle measurement of a non-right triangle. Or really it could be a missing side length. But really what I want you to focus on is the fact that it's a non-right triangle. So what tools did you use that you can learn today? There's actually two things that you can use to find the missing side length or angle measurement of a non-right triangle. So you need to answer that, and here are the directions if you need a review of how to complete the key phrase assignment. Otherwise, have a wonderful rest of your week, and let me know if you need any help as you're working on this week's assignments.